Gainandra, do you have a schedule? Dr. Sushil Kumar ji, good morning.
Good morning to everybody.
Morning,
Sir, good morning.
Yeah. Sir, Dr. M.S. Misra is going to welcome, isn't it, sir?
Yeah.
Okay.
That schedule I have sent to you on your email.
I have not seen. No, I'll check again. Now I'll find it.
Sushil sir, good morning.
Good morning, Dr. Murli. Good morning to everybody.
Sir,
Dr. C.T. Abraham Sahab, namaste, sir.
Good morning, namaste.
Sir. After a long time, I have seen you.
Yeah, I'm still alive, no problem.
Sir, again resend the mail, sir.
Abraham sir, good morning, sir.
Recently in morning.
Good morning.
Good morning to everybody.
Good morning, Dr. Sahab. Namaskar.
Namaste, sir. Namaste.
Sushil sir, send to me my Yahoo mail.
Yahoo mail.
Yeah. Please.
Okay. But I have one.
Good morning, Mr. Saab. Good morning. Good morning, Abraham sir.
Good morning. Good morning.
Good morning, sir.
Yeah.
सर चेयरमैन साहब जुड़ गए?
नहीं, अभी तो दिखे नहीं डॉक्टर साहब।
देख लो यार, क्योंकि उसे ज्ञानेंद्र से बोली, देखो देखो।
Sushil sir, no worry. I could see I received from Gmail also.
Oh, okay, okay.
Okay,
So kind of
okay. Okay,
thank
no,
you.
no issue, no issue.
Latest one, please see.
Yeah.
Morning.
Good morning, sir. Good morning.
Good morning, sir.
Sir, good morning.
Good morning, sir. Chinnaswamy sir, good morning.
Good
Good
morning,
morning,
sir.
Pleasant. Good morning. Good morning, Professor. Good morning.
Good morning, Chinnaswamy sir. How are
Yeah,
you?
good morning. Yeah, Professor Bhaskar. Good morning, Pleasant. Good morning to everyone, my dear colleagues. Dr.
Good
Sushil,
morning. Good morning.
Dr. Ravi from Pondicherry, then Professor HOD, Dr. Chinnamuthu,
Sir, good morning, sir.
Morning.
Professor Patel. Yeah, very good morning. Good morning to all of
Good
you.
morning to everybody, sir. Sir,
Good morning,
sir.
Dr. Sushil Kumar.
Sir, good.
Hello.
Good morning, sir.
Why so much beard?
Yes. Good
Huh?
morning.
Weed infestation. Weed infestation.
Yeah. Hello,
Sir.
Abraham sir. Good morning. Good morning to everybody.
Sir, very good
Hi.
morning.
Prasad
Bhaskar,
sir,
sir, good morning.
and
Good morning,
Morning,
sir.
Chinnaswamy. Good morning, Mishra.
Good morning to everyone.
Good morning, ADG sir. This is Chinnamuthu.
Good morning, sir. Chinnamuthu.
Yeah.
Good morning, all of you.
Ramchandra Prasad is there.
Good morning, Chamendra Prasad ji. Good morning.
Either Idraju has joined? No.
Yet to join.
Gyanendra?
From
Gyanendra?
Kerala. Gyanendra Singh.
Good morning, sir.
Gyanendra?
Good morning, Manjari from IAS Bhopal.
Good morning, Dr. Chinnamuthu. Good morning, Dr.
Morning, sir.
Mishra.
Good
Good
morning.
morning, Dr. Sushil. Good morning, Dr.
Good morning, sir. Kadiresan sir, good morning.
Good morning. Good morning. Good morning, Dr. Bhaskar.
Oh, good morning. How are you, Katreshan?
I'm fine,
Prasad
thank
sir,
you.
good morning. Prasad sir.
Good morning. Good morning.
Good morning, sir. Good morning.
Still in Chidambaram only?
Yes, I'm in Chidambaram.
Okay.
Dr. Sushil, let us start the proceeding.
Yeah. So,
Yeah.
Dr. Mishra sir. Dr. Chinnamuthu, please start. I think now which is the time.
Yeah. Very good morning to all. Namaste and namaskar. Today we are going to listen a fifth webinar on aquatic weeds. That is problems and their management for improving water productivity. Going to be delivered by Dr. Sushil Kumar sir. And we'll start the proceedings. I request the organizing secretary, director come secretary of ISWS and director DWR, Dr. Mishra ji, to welcome the gathering.
Yes. So, good morning all. It gives me immense pleasure to welcome the chairman of the program, Dr. S. Bhaskar Saab, ADG Agronomy, Agroforestry and Climate Change, ICR, New Delhi. In fact, he took a lot of interest in management of aquatic weeds, including We know that we cleared the Moti Jheel of the Motihari in Bihar. And likewise, since last so many years, he is taking a lot of interest on the aquatic weeds. So welcome you, sir, in this webinar for joining as a chairman.
Namaskar.
I also welcome our Vice President and convener of the program, Dr. Chinnamuthu Saab, Professor and Head, Tamil Nadu Agriculture University, Coimbatore.
Thank you, sir.
I also welcome our own colleagues, Dr. Sushil Kumar, who is the President of Indian Society of Weed Science, and the guest speaker of the day, who has very kindly agreed our request to deliver this talk on a very short notice. So welcome you, sir. We also welcome the galaxy of weed scientists, especially the senior weed scientist, Dr. N.T. Yadraju, sir, former director of this institute and the RSC chairman. Other weed scientist colleagues, Dr. Abraham, Dr. Chinnamuthu, Dr. Chinnusamy, sir, and Dr. T.V. Ramchand Prasad, and many more senior weed scientist colleagues, students, scientists from DWR, and scientists from ACRI Weed Management, students, ladies and gentlemen. So once again, I welcome you all for this webinar, and I hope that this will be very fruitful webinar, especially on the management of aquatic weeds in relation to water productivity, because we know that Government of India and ICR is giving a lot of emphasis on the occasion of the Bharat Ka Amrit Mahotsav. So we have tried to link this webinar under this program, how to improve the water productivity by the management of aquatic weeds in particular. So with this brief welcome remark, now I request the convener, Dr. Chinnusamy Saab, to go for further proceedings. Dr. Chinnu.
Thank you, sir. Thank you for our warm welcome to the participants and dignitaries. I also joined welcoming the Director ADG and the Assistant Director General ADG NRM, Dr. Bhaskarji. Welcome, sir. And also I welcome our Director DWR. Of course, he is the Organizing Secretary as well as Secretary for our Indian Society of Weed Science. Thank you, sir. Thank you for your welcome address, and also I welcome you, sir. And our most respected and beloved Dr. Sushil Kumar, sir, who today is going to be giving the seminar, webinar on these aquatic weeds. Sir, I am also joining the, along with Mr. Jaf, welcoming the Sushil Kumar, sir. And our veteran scientist, Dr. Yadraj, sir, Chinnusamy, sir. I hope A.N. Rao, sir, also going to join. Abraham, sir, also joined. Adiresan, sir, Dr. Prasad, sir, and so many senior scientists and ISW members, IW state councillor, scientists, and attending from other abroad also. I think Muthukumar and Chauhan is also going to join right now. And scientists and professors from India, research scholars and students, friends. Once again, good morning to all. I also welcome you for this webinar. So based on the request of our ISWS, all of you are joined. I think more than 455, 56, 57 is going on, adding participants are already joined. So it is one of the important webinar to help us to manage the aquatic weeds effectively. So a few words about before proceeding the seminar, webinar by Dr. Sushil Kumar. Dr. Sushil Kumar is the president of Indian Society of Weed Science, and he is a weed entomologist working in the ICR Institute for more than 35 years. He is specialized in biological control of weeds, aquatic weed management in crops and cropping systems, herbicide tolerant crops, and he is working aquatic weed management alone for more than 30 years, and he is testing so many biological agents for controlling the aquatic weeds, especially water hyacinth, as well as other weeds in the both in aquatic environment and as well as wetland fields. So he is an eminent weed entomologist. Is going to speak on the today's presentation on aquatic weeds, problems and their management for improving water productivity. A few words about the aquatic weeds before letting the speaker to deliver. Aquatic weeds are those unabated plants which grow and compete their life cycle in water. and cause harm to aquatic environment directly and to related to eco environment relatively. So management of these aquatic weeds are highly challenging. We know everyone, it's very difficult to challenge, very difficult to control. Use of chemicals pose problems of contamination of waters, as well as suitable machineries also were not available for mechanical removal. So with respect to biological control, survival of biological control agents are questioning in the off seasons. So it's not able to maintain the population during off seasons. So this is also a problem with the biological control means. So the today's webinar certainly will throw some light on the issue address, since he is having long experience and having wide knowledge on this topic. So it will be highly useful for the young agronomists as well as students friends. That's why we have given wide publicity for the undergraduate and the PG and PhD students as well as the young agronomists. So in this context, I request the speaker to deliver the this topic. Before that, I request the chairman of this webinar to give his introductory remarks. Dr. Bhaskar ji, please, sir.
Dr. C.R. Chinnamuthu, Convener and Vice President of ISWS, Professor and Head of Department of Agronomy, KNA Coimbatore. My beloved director is there, Dr. J.S. Sharma, Organizing Secretary, ISWS, and Director of the ICR DWR Jabalpur. And of course, today's guest speaker, Dr. Sushil Kumar. Of course, I know him since last 6 years. He is going to go do a good job. First of all, let me compliment and congratulate the team of ISRA and team of ISWS for a series of webinars they are launching, and they are attracting many people. And this platform has provided during the COVID times that we can share the knowledge, particularly in the field of weed science, advances in weed science and all those things. Many senior weed scientists also have joined this. I think they will have many more questions to ask at the end. I am very much sure that the Sushil Kumar is going to answer all of the questions. And the theme is aquatic weeds problems and their management for improving water productivity is being organized in the context of commemorating 75 years of India's Independence Day. Of course, there are a series of webinars that have been given to different institutes. Different institutes are also engaged in different organizing webinars, and day in and day out, we have been attending the even campaigns. We have been given to go for campaigns, the mass awareness campaigns on certain aspects. That also we are doing it from the council side. So coming to today's topic, our theme, which has been asked, of course, we are all aware that India is home for 18% of global population. But what is the amount of water we are having? We are having only 4% of the global water. And now, presently, the per capita availability has come down to 1,100 cubic meters per person, of course, which is much less than the international standards of 1,700 cubic meters. So that is one aspect. Second thing is in India, if you see, about 5.3 million hectares are being water bodies, are occupied by the water bodies. Maybe in the form of reservoirs, 1.9 million hectares, or 1.2 million hectares are under canals, irrigation canals. Of course, many of the irrigation canals in India, they are season bound. They may not be run, particularly if you go to South India, many of the irrigation canals are season bound, except in the northern India, which are the rivers which are fed by the glaciers, they run throughout the years. That is the thing. And out of this 5.3 million hectares, again, it has been estimated that only 1 million hectares, amounting to 20%, is affected, infected, or invaded by noxious aquatic weeds. That is a kind of scenario we are seeing that. But this is only estimate, and we don't have accurate thing. We have not so far mapped also. We don't have database of entire water bodies in the country. To what extent aquatic weeds have infested. And if you go to some of the northeastern parts and also some of the Kuttanadu area in the south also, many of the areas have been infected by the weeds. But whether they are affecting the economy of such water bodies is more important. Mainly the economy of such water bodies, fishing may be affected. Another one is navigation may be unaffected. But if you want to have some kind of the data on the water bodies, particularly wetlands, which has been estimated in one of the NICRA projects by CIFRI, Barakpur, that is Central Institute for Fisheries Research Institute. And they have, of course, they have evaluated these water bodies and wetlands mainly from the angle of the ecosystem services, how much they can contribute for the carbon sink, just similar to the mangroves in the coastlines. So they have estimated that. That kind of database is available for reference. And of course, it is a very good reference for the weed scientists also. They can also learn about so many things about that. So then coming to the most important, water is, why we have to worry about the water? Water is the most important natural resource, which is sustaining life on this earth. And the management of water resources is very, very important. From its source to utilization point, there should not be much losses and all those things. And if you see the aquatic weeds, of course, about 160 species have been known to occupy the water bodies, aquatic bodies. Out of them, we are concerned about 12 species. Again, in that, I can say that Eichhornia, Salvinia, and Ipomia and Typha are the major ones. If you look at the other ones, actually, Nilambu, they have recorded as a weed of aquatic weed. But if you go to certain places in Karnataka and Tamil Nadu, Nilambu is an economic activity. Say they harvest the flowers and offer to the gods in many festivals. So that is a kind of this thing. Whether it is affecting the other activity, fishing and the navigation is more important. So that kind of things are also there. And Mishra also is coming from the water plus areas of Bihar and other things. Many of aquatic plants have economic value, particularly Makana and Singada and all those things. He has worked with that. And we have got an exclusive station for studying aquatic plants and aquatic systems. So that is also another part we have to know about that. Then coming to the losses of causing by these weeds, of course, people are saying that some irrigation projects have reduced their efficiency, particularly in terms of duty of water. So earlier they used to irrigate large catchment area. Now the catchment area has come down. That means duty of water stored in that particular reservoir might have gone down. So to name few such irrigation dams, Nagarjuna Sagar is there in Andhra Pradesh, and Tungabhadra project. Of course, Tungabhadra project in Karnataka, they also contribute this for the sedimentation, not necessarily for the aquatic weeds. I know very well that. And the hydroelectric projects in Kerala and that is particularly Kakki and Idaki project, their capacity of hydroelectric power has come down. That is also one of the reports are there. But main problem worrying is the evapotranspiration losses being caused by the aquatic weeds. So you say that when weeds or crops are there on the crop soil surface, no doubt transpiration losses are much more than the evaporation losses. It's not of the plant's canopy is going to cover the loss of the soil surface. Only few pockets will be exposed, and therefore the evaporation losses will be there. But I also put one question to the presenter as well as the other intellectuals who are there here. When a water body is completely covered by an aquatic weed, so what is the transpiration loss? Is it equal to the evapotranspiration of the pond with and without the aquatic weeds? That kind of some information has to come from this group. I think it's a lot of questions will be arised like this. So people ask that whether how much is the carbon sink if weeds are there. Particularly when the economic activity is being affected, we can think of its control. But if it is in the natural lakes where the water is not being used for any other purposes, even for irrigation. So under such situation, what is the contribution of these aquatic weeds for the carbon sink, and what is its contribution for the biodiversity angle also, we have to look into those things. Then, of course, because of the translation losses, it reduced the storage capacity, no doubt, reservoirs. Therefore, it reduced the duty of water from such reservoirs. Mainly, fish production is affected in some cases. We have seen this in Manipur Lake. Of course, many traditional fish fishermen are there, and they are not even, I have been telling them to go for some modern fishing techniques of cage culture and all those things that they are not adopted. When you adopt that, so then what is the interference of the aquatic weeds for in fishing? That is also should be known. And navigation, of course, everyone know wherever canals, particularly irrigation canals, where it is being used for the navigation purpose, that is required. And it also reduces the conveyance efficiency. That means, suppose part of the canals, it may not be the major canals. There are so many classifications is there, minor canals, secondary canals, and all those things. Some of the canals, if they are going to be converted in due course of time through piped water irrigation, then of course much of the problems of weeds, which are going to reduce the conveyance losses, is going to be reduced. If you come and look at the management options, of course, we have got several methods. It has been listed in the textbooks as well as the other way of places, physical, mechanical methods, biological methods. Each one of them will have their own limitations. They have their own advantages, merits and demerits. And looking at the situation where this has to be applied, particularly mechanized cultivation, mechanized control of weeds may be much more useful compared to the chemical methods, because we don't have that much expertise. Maybe suitable for the small ponds to be treated, but not for the big lakes, which we have done in Motihari, which was having about 500 acres. We put our soul and strength there to clear up the Motihari lake. And very small, compared to that, the small lake has been also been cleared in Karwar, long back in Karnataka itself. And later on, looking at the clearing of these things, we have received the request from the Kerala entire policy makers that we have to clear the Kuttanad area. It is about 50,000 hectares, and we have estimated the cost of 50 crores. I don't know what is the status of that, but biological weed control, no doubt, it is having some potential and some scope for controlling weeds under water bodies. Let us listen to the speaker, how he is going to put forth the views of these things, particularly about the loss of aquatic flora and fauna is there, or he has to also come out with what is the biodiversity conservation also. That is also more important. Loss is there. At the same time, we have to see the balance, or we have to see the trade-off between the loss and the gain of the flora and fauna or water biodiversity and all those things. So I request this group to come out with a correct estimate or a mapping of the lakes where the weed problems are really posing the problems. And I want that kind of information, and we'll see in the days to come. I wish them once again all the best for organizing such a beautiful seminar, national webinar during the Corona period. And so more than 500 people have joined. Very good strength. Many of them are young budding scientists, and they should listen till end, and they should also apply their mind, and whatever the questions are there, they let them rise on the chat box, and it will be answered by the speaker at the end. Thank you very much, Dr. Mishra, Dr. Chindumuthu, Dr. Sushil Kumar. Please go ahead with your event. All the best.
Thank you, sir. Thank you very much, Chairman, sir, for giving the scenario of water resources and the effect of aquatic weeds on the water bodies and their options for management. I think you have raised some of the issues and questions. I hope this speaker will address some of the issues raised by you, sir. And now let us invite the speaker, Dr. Sushil Kumar, sir, to talk on the topic aquatic weeds, problems and their management for improving water productivity. Dr. Sushil Kumar, sir, please.
Thank you very much, Dr. Chinnamuthu. And first of all, good morning to everybody. And I start my presentation with the thanks to Chair, Dr. Bhaskar Saab. In fact, I want to tell you that in our earlier webinar series, Dr. Bhaskar Saab, Dr. Yaduraju Saab, and many others, they showed the interest in aquatic weed problems and management. And their feedback during past webinars led DWR and ISWS to talk about this aquatic weed problems and management. So I welcome our Vice President, Dr. Chinnamuthu sir, and our Secretary as well as Director, Dr. J.S. Misra. And on the screen, I am seeing very renowned weed scientists who are available here attending this webinar. Dr. Like I welcome all like Dr. Yaduraju sir, Dr. Chinnaswamy, Dr. C.T. Abraham, Dr. Punya sir. I'm also seeing Dr. Kathir. There are so many legends of weed scientists are taking part or participating in this seminar. I welcome all you at this juncture, and I see that so many students are also participating. Definitely, we encourage students too much, and I hope that students will be benefited a lot to attend these sort of webinars being organized by Directorate of Weed Research as well as ISWS. With this introduction, I start my presentation. As you are knowing that this talk is being made on aquatic weeds problems, and in his introductory remarks, Dr. Bhaskar sir, he has rightly pointed out many weed problems, aquatic weed problems, and about their managements. Here I will try to justify the talk in context to aquatic weed problems and management. So friends, you all know that aquatic weeds are those unwanted plants growing in water and complete at least a part of their life cycle in water. So in fact, among the weeds, if we talk about the aquatic weeds, so we will call all those unwanted plants which complete at least a part of their life cycle in water. Then we can say them as aquatic weed. And aquatic weeds can be grouped into algae and hydrophytes. And if you will see classification of aquatic weeds in general, we all know that these are the surface weeds floating. As many of you are also knowing the submerged weeds which remain below the water, immersed weeds which come out from the water and their upper part remain out of the water. Like this, we can also in journal we say that these are the shoreline or ditch weeds, these are the bank weeds or marshland or swamp weeds. So as rightly pointed out by Dr. Bhaskar sir, that if we talk about many aquatic weeds, so out of about 10 aquatic weeds, we can categorize them as the primary concerns to our country. And out of that, number one weed is Eichhornia crassipes, means water hyacinth. You all know well that water hyacinth has become one of the greatest problem in India. And after that, Nymphea, submerged weed, Hydrilla verticillata, Typha, Ipomia species. In Ipomia aquatica, as well as Ipomia carnea, Salvinia, Nelumbo, Vallisneria, Chara, and Lamna. These are major concerns. But recently, this Alternanthera phylloxerates, which is commonly known as alligator weed, has become a growing menace in water bodies in India. And earlier, we were not seeing this Salvinia molesta type of weeds in our central India and North Indian conditions, but it is expanding its range, because now we have seen for last couple of years, we are seeing that this Salvinia molesta is spreading fast in central India, and I'm sure from the central India now it will lead toward the North India. So now we can say that aquatic weed problem is everywhere. And if you, these are a few photographs of the weed species, Ceratophyllum species. This is submerged weeds, Pistia statoides. This is also coming as one of the big problems in rivers, this Pistia. And Chara, Hydrilla. Hydrilla is one of the greatest problem in aquatic bodies, and it is the submerged weed. Like this, likewise, Naza's, Potamegaton, there are several species of Potamegaton. Nightella species are the problem in aquatic bodies. This is about the alligator weed. In fact, because it is emerging weeds, and we have studied in great depth about this alligator weed, and find that it has immense capacity to regenerate. From here, just we cut a node and just send to the water, and you are seeing that from that single nodes, without having any other parts, it is emerging. So that's why from every node it has the capacity to emerge. As the name alligator weed means, it can thrive well in aquatic situations as well as in terrestrial situations. That's why its management is really a big problem. And nowadays you are aware that this the problem of this alligator weed has come in many crops also. So this is one of the emerging weeds. You all know about this water hyacinth, this beautiful. In fact, due to this beautiful flower, this came into India in 1895 around, and now these beautiful flowers have become very problematic to our all type of aquatic weeds. Either you talk about this perennial or substantial form of the aquatic ponds or rivers. Everywhere you can see the menace of water bodies. Uttanand area, as Dr. Bhaskar Saab told about that region, mentioned about that region, it is having greatest problem in Uttanand area. In whole northeast area is suffering due to this water hyacinth as well as other weeds. So problems caused by aquatic weeds, the scenario or a brief introduction has been given by our chairman. Of course, just in a nutshell, we can see these are the problems caused by aquatic weeds. So here I will not repeat it, but I will try to give the answer of Dr. Bhaskar Saab. He was interested to know that how much evapotranspiration occurs due to the weeds. So here I will bring to the notice of all that, yeah, in fact, one of the aquatic weeds, that water hyacinth, it has been well studied about the evapotranspiration, and you will wonder that about 9 to 11 time more evapotranspiration occurs due to the water hyacinth in comparison to the open pan of the water, whether it is in pond or it is in river. So that is the reason that certainly these are the great problem causing in reduction of the water. And we all know that other aquatic problems, so I will not repeat here. I will go in next slides. You are seeing this is one of the Bhima River. It was near Pune, and here you find that this weed is called Pistia. And you see, if Pistia will be there in aquatic ponds or aquatic these rivers, certainly there will be so many problems will come due to this aquatic weed particularly. And we have conducted a study of this Pistia at our Directorate of Weed Research also, and found that greatest water quality means water that dissolve oxygen will be greatly reduced in the presence of this aquatic weed Pistia. It means it is able to reduce the dissolved oxygen level from 6 ppm to up to 1 ppm. So you can see that whenever if a aquatic pond or aquatic body will be infested with this Pistia, then certainly dissolved oxygen will be reduced drastically, and it will cause the death of fishes and aquatic fauna. This is a scene of aquatic weed problem in Uti Lake. Earlier, there was a lot of hue and cry because water hyacinth started to infest this Uti Lake. And after intervention of the government, then a program was run, and after having big investment, this lake was cleared from the water hyacinth. But still, there are reoccurrence of the water hyacinth and other aquatic weeds time to time. Why matlab this reoccurrence occurred? Because they water hyacinth and other weeds, they are having great seed production capability, particularly in context to water hyacinth. The seeds are able to grow or regenerate even after 20 years of its burial in the mud. So you can, that's why this is the reason whenever we do mechanically remove the weed from any aquatic body, there will be reoccurrence of that weed, and in context to water hyacinth, it is very much pertinent. And you see here, this is one of the Kharkai river in Jamshedpur in Jharkhand, and about more than 15 kilometer whole river path was blocked by this water hyacinth and municipality, and there was so many cases of death due to drowning of the people there. There was upsurge of the dengue cases, and really that was a big problem, and that was the reason the Jamshedpur municipality, they approached Directorate of Weed Research, and I was assigned the duty to go there. I will discuss the management part later on. It was also a successful example of management. And here you see Dr. Bhaskar Saab, he mentioned about the Motihari. In Motihari Lake, it is badly infested, and due to the intervention of our past agriculture minister, Dr. Radha Mohan Singh ji, we did there some demonstration, and we managed a weed in about 5-acre aquatic body there. And also then we converted that into the vermicompost. So that was also a demonstration of integrated management of water hyacinths. So this is alligator weed in Vulur Lake. And Dal Lake, you all know that beautiful Dal Lake. Many of you might have visited Dal Lake, and you will see that in Dal Lake, lot of weed problems. In fact, because weed problems is so much severe that they have to run throughout the year the removal programs of the weeds. Water hyacinth is there, alligator weed is there, lily is there, and so many submerged weeds are there in Dal Lake. That is the reason that they are very worried always about the management of aquatic weed in Dal Lake. You talk about this Kutanand area, everywhere, if you will go, particularly in November, December, everywhere in every canal, you will find this sort of the situations. So this is also one of the, likewise in Northeast region, every Northeast region is infested with the aquatic weeds. And in Punjab, if you will talk, canals are often infested with water hyacinth and other alligator weeds. And these are some of the photographs regarding infestation. And you know that particularly in canals and particularly in dams, we are receiving many inquiries from water authorities, like from dam people or canal management people. They are facing greatest problems of aquatic weeds. And this you see the flow of how this aquatic weed problem is there in canals. These are all submerged weeds. In that this hydrilla and algae problems always persist. And in many parts of the India now, micro irrigation projects are running, and they are facing great problem due to these algae and aquatic weeds. So now we talk about the management methods. Friends, you all know that there are many types of the management methods. Like we can categorize them like preventive method, mechanical method, manual method, chemical method, biological method, cultural method, likewise this. And here I will try to give a scenario of different approaches of aquatic weed management. First of all, we talk about this preventive management. Of course, this preventive management may play a very important role for the management of the aquatic weeds. How this I will tell you in forthcoming slides. But certainly, if we talk about the quarantine may be a legislative tools for the management of aquatic weeds from one region to the other region. For example, I was talking about the upsurge of Salvinia molesta now in central region. So if we would have taken the quarantine measures from one state to other state, and if we would have also taken some measures to block or to prevent the flow of aquatic weeds from one river to other river, from one dam to other canals, then certainly it may play a very important role to manage the aquatic weeds. And there is a need of strict implementation of quarantine laws in India. And I am sure, I tell you, that if this is preventive management laws are implemented in toto and with the sincere efforts, we may check a lot of problem of aquatic weeds. For example, here I will give you the example of Jamshedpur. I was talking that they were very, there was great menace of this water hyacinth, and I gave simply preventive, I applied here simply preventive methods. You see, I gave a plan to them that a few points barricading should be there with a strong wire mesh. Emphasis was given to monitor the 15 kilometer to 25 kilometer riverway from December onwards, and suggested to remove the germinating small water hyacinth from the water course particularly. And in fact, the municipality and other leading industrial people, they followed our suggestions very sincerely, and they appointed a full-time contractor to remove the emerging water hyacinth in the course of rivers, and exercise continuous on daily basis with a team, and supervised done by the officers. I tell you, just by a simple biology, by knowing simple biology of the weed, and by this preventive methods, that water hyacinth problem was completely solved by the next year. Because here I suggested them to take the advantage of regeneration. What happens generally, particularly in canals, such big canals and reservoirs, during rainy season due to flood, all water hyacinth washed away and go to the ultimately go to the sea. But after cleaning of that water hyacinth, if we take some proper attention to that river or canal, certainly with very less expenditure we can manage the problem of aquatic weeds. And results were outstanding. Not a single spot in both rivers were found infested. And you see, this was the condition. This was the previous year condition. The whole area was full of water hyacinth. They engaged because they tried to engage people when water hyacinth problem was already there. But here, after when they implemented the implementation program before the upsurge of water hyacinth, then they got this success. And this was the reason that next year there was no blockage of water hyacinth, no infestation of water hyacinth, no drowning case, and there was great, very high reduction in malaria and dengue cases also. So likewise, preventive method can lead successful management of aquatic weed in micro irrigation projects. I here share with you the Tikamgarh example. In fact, in Tikamgarh, micro irrigation project is going on, and they are very much, the authority there who are doing this, they are suffering great obstacles in managing micro irrigation program due to the infestation of this aquatic weeds, and particularly in those aquatic weeds, the menace was algae as well as hydrilla. So here, what they did on our suggestions, and they were also implemented this sort of checking barriers. And I suggested other checking barriers to make there. And of course, because here is the irrigation project, so we cannot think of about chemicals, but certainly by preventive approaches, we can manage the weeds infestation in such sort of canals. and they are very successful in their approach. And later on, because here in such canals, we also have the facility to block the water or drainage into the canals. So after waters, later on that canal may be treated with the lime, etc., to kill the seeds or some micro that parts of the algae or hydrilla there on the that floor of the river. So by this preventive management methods, we can manage such sort of the problems. And you talk physical, we all know about the physical removal, and we all know there are different tools and techniques of the mechanical control of aquatic weeds, like netting, barriers, chaining, dredging, draining. And weed harvester, you all know, you might have seen that weed harvester and cutters are available nowadays there, and they are cutting micro inside, they are cutting the weeds from the below surface level, and then they carry on later to the banks. So likewise here I would like to share you some weed harvesters through these. In fact, nowadays these weed harvesters are being they are using in great way. Weed harvester, if you see these JCB, in fact JCBs are being implemented a lot throughout India, and this has become one of the most important mechanical tools. And this is the scenario of Dal Lake. From Dal Lake, always they do always this sort of manual removal of the weeds. In below pictures, there were the lily is being removed from the farmost area of that Dal Lake, and now it is being carried out for dumping on the river bank. Likewise, algae problems are there also. You see, we were talking about the netting, etc. So here you add to submerge weeds, these sort of tools are observed. And here you see that how mechanical, some Jugaad technology, particularly in India, some Jugaad technologies are also being implemented. This view is of Hyderabad. From in Hyderabad, they have done this mechanical removal of the water hyacinth and other aquatic weeds by developing some tools or mechanical harvester type of things. Or here in that this lower picture, there are removal by the conveyor belt. So we talk about the chemical management also. It is very effective, no doubt. And but particularly in India, so far 2,4-D has been registered for water hyacinth. However, many herbicides are claimed to control aquatic weed, particularly floating weeds. So friends, here I would like to share that particularly in Indian situations, registered molecules are almost nil except this 2,4-D, but a lot of research has been done to manage the aquatic weeds, and among those molecules 2,4-D, paraquat, glyphosate, and metsulfuron methyls are most prevalent herbicides which have been reported to control many types of aquatic weeds. And particularly whenever we talk or we try to recommend aquatic these herbicides to manage aquatic weed problem, always there are concern about the of environmentalists. For example, recently in one of the Sarni dam area where we recommended this herbicide to manage terrestrial weeds on the bank sides, people, they did not allow. In fact, later on, environmentalists came forward and they objected even to use chemicals on the bank of the far bank of the river. So this is the condition. That's why we have to think about other available approaches, a part of chemical approaches. And here, this is the view of management of Nelimbo lotus in Adhartal pond of Jabalpur. Of course, here we applied metsulfuron, glyphosate, and 2,4-D, and we found that this metformin was emerged one of the good herbicides to manage lotus, but repeated spray of herbicide is required because they are very tough weeds. They are having their stems or roots inside the river on the floor of the ponds. So that is the reason after sometimes after about 3-4 months again the regeneration will start. So this is the greatest problem of the management of aquatic weeds. And this is about, now I talk about the biological control. Of course, biological control is very successful in some of the cases, particularly for water hyacinth and for salvinia. We are having very good bioagents. For water hyacinth, this Neocatina species we are having. Neocatina species bioagent has done very remarkable management of water hyacinth in many ponds of the India. And here I will also say that biological control is not only the single solution for the management of aquatic weeds, because host specificity is one of the important criteria of the water hyacinth, of the aquatic weed management under biological control program. But we need a very host specific bioagents. That is the reason we are having only bioagents only for some limited aquatic weeds. We are having bioagents for water hyacinth, we are having bioagents for salvinia, and both bioagents are playing very important role to manage water hyacinth and salvinia in India. Of course, in other countries, some bioagents are also helping to manage aquatic weed like alligator weed, like pistia. So we need to import those bioagents into India. For this is one of the examples of successful biological control. You are seeing in upper picture, it is full of water hyacinth, and in the last picture, it is complete clear without clear from the water hyacinth. It means this is the act of biological control by the bioagents. But this bioagents are also having some limitations. So this type of scenario has occurred after 3 years of continuous efforts of the bioagents. So if we want very quick management of this water hyacinth or salvinia, we need to wait, because time is the constant limitation. Other limitation is that it needs the perennial ponds. And this biological control agents, they will not work in running water. Means if we want to apply, for example, I was showing you the river of Jamshedpur, and if we wanted to control using bioagents, we cannot make use of that bioagent there, because population, the whole scenario of bioagent biological control depends on the population buildup of the bioagents. So in running water, there will be no proper population buildup, and by the time good population buildup will be there, flood will come and the whole that population will wash away. This is the reason it needs very specific conditions. And this is the recent success story of management of water hyacinth by Neocatina in Gwalior region. And like Gwalior region, there are throughout India, there are very many successful theory of or successful story of management of water hyacinth by Neocatina species. This is Salvinia molesta. I was talking about the Salvinia molesta. It is great problem in northeast region, and as well as also in Kerala. In biggest problem it was. Now due to the continuous attack by the bioagent Cetobacter salvini, this is not a now very big problem in Kerala. Every year this bioagent is controlling salvinia. Of course, because it is a continuous process, again salvinia will regenerate, and again there will start of the population buildup. Like this that scenario starts. With this successful story of biological control in Kerala, now we are doing experiments of biological control in central India, in Jabalpur area, and we are very happy to share that this bioagent is also working very nicely in central Indian climatic condition. I hope that in coming days it will be able to manage the salvinia in central India also. Now, little bit we should talk about the integration of chemical approach as well as some biological approach. Some experiment has been done on this at DWR and in other institutions, and certainly we may reduce the time taken alone by the bioagents or we apply the chemical. Of course, we integrate chemical control with the biological control. We should be very careful about the spray of the chemicals. We should not recommend the blanket spray of chemical to manage water hyacinth or aquatic weeds, particularly when we are talking about the integration of bioagents and chemical. So only about 15% area should be sprayed with the chemicals, and in other areas these bioagents should be released. And in due course, this bioagent, they will increase their population, and certainly they will manage the aquatic water hyacinth problem like this here. But there will be again regeneration of the water hyacinths. Again, water hyacinth biological bioagent will be population will be increased, and likewise within 2-3 years the whole area will be completely controlled. And here time taken alone by the bioagents will again be reduced to about 12 to 15 months. So by integration of about 15% area with chemical spray, we can reduce the time taken alone by the bioagents. So here, of course, the drastic that feature of bioagents is that you will not find that formation of flower by within 9 months to 12 months. There will be complete blockage of the formation of flowers. So that's why these bioagents play very important role in management of this water hyacinths. And some work has also been done by Dr. Kathiresan on this allelopathy. Coelas ambonicus, he found very useful when he integrated this with the chemical as well as alone. Some experiments were done, but again the problem is that regeneration problem. Within very fantastic results, within one day the whole plant will be dried up and it will look that they have now completely killed. Of course, very small that those plants may be able to kill, but later on if plants will be high, they become regenerate. So here successful example of integrated management in one of the very big ponds in Halial Dharwad region. And you see with the chemical management, with the mechanical management, with biological management, we demonstrated of the management of
सर स्क्रीन पे ना आपके उसमें स्टूडेंट लोग थोड़ा वो कर रहे हैं, तो आप एक काम करिए ना, उस पे सर ऊपर सेटिंग में जाइए।
हाँ,
ड्रॉ करके आ रहा होगा ऑप्शन सर।
अब सुनो, अब ऐसे चलने दो तो ठीक है। इसमें अभी देर में फिनिश करता हूँ 10 मिनट में।
सर उसमें ड्रॉ करके आ रहा होगा, उसमें देखिए इरेज लिखा हो, क्लियर लिखा होगा सर, क्लियर कर दीजिए तो ये पूरा बंद हो जाएगा।
सेटिंग में
नहीं, ऊपर सर देखिए, ऊपर आप माउस लेकर जाएंगे ना स्क्रीन में, बीच में ऊपर सबसे ऊपर टॉप पे
जहाँ न्यू शेयर लिखा हुआ है,
नहीं ऐसे स्क्रीन में सर अपने सबसे ऊपर माउस लेकर जाइए तो वहां पर आपका ऑप्शन दिखाई दे रहा होगा, टूल्स दिखाई दे रहे होंगे सर।
हाँ, सेटिंग में जाऊं?
सेटिंग में सर, सेटिंग में नहीं जाना है, उसमें बाहर ही दिखा रहा होगा सर टूल्स, जिसमें कर्सर वगैरह दिख रहे होंगे ना सर, कर्सर टैग्स।
हाँ हाँ, आई सी।
एक जगह क्लियर लिखा होगा।
क्लियर? नो, आई एम नॉट, यू आर स्क्रीनिंग स्टॉप वीडियो।
10 मिनट में खुद ही कर रहा हूँ, 2 सेकंड सर।
तो अपने वहीं से कर सकते हो तो वहीं से कर लो।
10 मिनट में देख रहा हूँ। नहीं सर,
अभी मैं रुकूं क्या थोड़ी देर के लिए?
सर वो आपके स्क्रीन में है। हाँ, हो गया, ठीक है।
अच्छा, सॉरी फ्रेंड्स,
इसमें आगे एक मोर ऑप्शन होगा सर।
अब सुनो, अब खत्म होने दो, रहने दो अभी। यहाँ पर मतलब इट विल बी वेरी हार्ड टू मतलब डू सम ऑल दीज थिंग्स ना। So friends, sorry for interruptions because there was some problems from the participants. They were, I think, hitting some points due to which there was some disturbance on the screen. So friends, we were talking about the Halial examples of demonstration integrated managements. So in Halial, we did this very nicely. And after that, if we talk about we also demonstrated the integrated water hyacinth management in Moti Lake, which was infested with the water hyacinth. And here you see, just to reduce, because you know, wet water hyacinth is having a very heavy weight. So just to reduce the weight, here what we did, we initially we sprayed the chemical over the water hyacinth and waited till it dried. And after when it was half dried, then we tried to remove. So by this way, we were able to remove big water hyacinth infestation from big area in less expenditure. So these techniques may also be applied to reduce the biomass of water hyacinth. But here again, because we need to remove the water hyacinth or aquatic weeds 2 times, because first of all we have to spray and then we have to remove. So the expenditure become almost equal if we applied alone the mechanical removal. So we found that better. But many people, they recommend this one, and later on we found that this tactic is not very economic viable. But here what we did, whatever this biomass we removed, we also demonstrated to make compost from that removed biomass. So here in the last picture you are seeing that we have gathered, we have accumulated all the biomass there at one place, because biomass was so huge. For turning, we employed JCB, and you here see that about more than 100 tons of vermicompost was prepared from the peat biomass, which we removed from the ponds, Motihari ponds. So friends, here what I want to share, that if we have to employ mechanical methods to remove the water hyacinth, I think it will be much better if we do some utilization of the weeds also. And utilization is also a way of management. For example, if for many aquatic weeds, we can do some things. For example, water hyacinth, people are making biogas, people are making some domestic things are also there. So, but we have to see that which method will be, which utilization method is cost viable. If it is a cost viable, certainly people will be attracted. In case of this making vermicompost from water hyacinth biomass, we found that it is cost viable. Why? Because whatever expenditure we have to done, we have already done to remove the water hyacinth from the aquatic body. And but if we utilize that biomass for the good purpose, then I think it is a very good approach. And now there are some recommendations or way forward points also about the aquatic weed problems. And the problem needs to be tackled through a comprehensive integrated plan involving physical, mechanical, and chemical, means all approaches. Because if we will, and it is need based also. As I was discussing that Kutanand area or Jamshedpur area, in Kutanand area, for example, Bhaskar sir, he told about that the whole great water canals are choked by the water hyacinth. But I am sure during rainy season, due to that heavy rains, due to the flow of water, almost those canals become clear during rainy seasons. But after rainy seasons, stopping of the rainy season, again there will be regeneration of the water hyacinth, and this is the time where we should give our interruptions. For example, here if we monitor those canals and remove those less very small water hyacinth seedlings from the aquatic body, then certainly the expenditure will be very less in comparison to when all canals will be blocked. So this preventive approach may be very much effective to manage particularly these floating weeds. Particularly, I am talking about floating weeds. Particularly these floating weeds, keeping in view the rainy season scenario, as well as applying the preventive management. Of course, there are so many machineries are employed, as we have seen, that JCB machines or very big harvesters. Harvesters are very costly, but people are now using Jugaad technology, and they are making conveyor belt to remove the that floating weeds and then convert to them some utilizable purpose. And they are also using different type of mechanical tools to remove the floating weeds particularly. And we need to ensure participations of the stakeholders. For example, if we want to manage the aquatic weeds in some lakes and ponds surrounding with the habitat, human habitat, then we have to motivate them to make the societies and to make clear the aquatic bodies. For example, I will share my experience with the one NGOs in Bangalore. In Bangalore, in fact, there are so many lakes in Bangalore. So those NGOs, they wanted our input about that. Then we encourage them to, after removal, we encourage them to make the societies. And now they have done this, and certainly they are doing very good job. A few lakes in Bangalore are clear, and they are maintaining now, because now they understand that if they will allow the regeneration of the weeds for some time, then whole that lake will be infested with the water hyacinths or other aquatic weeds. So this is the reason wherever we suggest this sort of management tactics, we should try to motivate inhabitants there to make societies to clear the water bodies. And for example, recently from Gujarat, near Ahmedabad, NGOs, they wanted our inputs to manage 5 lakes there, and we have suggested them our management inputs, and we encourage them to make such sort of societies nearby. And I'm sure that in due course they will be doing that one, and by that way they will be managing those lakes. So friends, this is all about this aquatic weeds problems and managements particularly, and that too in context to the water management also. Thank you very much.
Sir, may I know some measures for Typha grass, sir? Typha grass.
Yeah, and please, tell me.
For me to unmute. Let me start the discussion. Before that, I thank the speaker profusely for your elaborative information and sharing your experience on the aquatic weeds. Actually, you have taken us virtually to the sites of aquatic weeds infected areas of different places in India without involving any cost and other things. We have enjoyed your pictures and the management aspects with so much of pictures and all. So I hope this information will be very much useful to our young agronomists and student friends to work further on these areas. So it will give some confidence on the students to work and take forward further to manage this kind of weeds. Now I invite the eminent scientist, I think C.T. Abraham sir. Let us go for discussion a little bit later. I think Dr. Abraham is more relevant person, is having more affected areas in aquatic weeds. I request Dr. C.T. Abraham sir give some few words about this aquatic weeds. Dr. Abraham sir.
It was a nice presentation. As he told, Sushil Kumar has taken us to various parts where biological control was successfully implemented in along with the other methods of control. as he told, I'm from Kerala, and we have a large area under water bodies severely infested with aquatic weeds. And our earlier work by our former entomologist, Dr. Joy, he was concentrating on biology control of Salvinia molesta when it infested the Kuttanad area, the aquatic areas. And we have introduced the biological Streptococcus salvinia, the weevil, and that was released. And after about 2 years, we could get good control of the weed. As Sushil Kumar told, once the weevil establishes, the population of the weed will come down, and there will be a stage when there won't be enough food for the weevil, and then the population of the weevil population will come down. At that time, again, the weed will go on multiplying. So what we are getting is alternating cycles of the weed as well as the biological control organism. So in any biological control system, we will never expect a complete eradication of the weed. What we are expecting is only a balance, and so that there will be, the weed will be there, the weevil will be there, the organism will be there, and the weed will be in a manageable level so that we can continue our activities like that. Whereas our experience with Eichhornia, wherein we had introduced Neocotina eichhornia, a weevil, as well as a mite for controlling this weed. Both these have got established in our aquatic system. Wherever you go, you'll see the leaves of the Eichhornia infested by these organisms, and we can see the action. But what we are finding is the growth of Eichhornia is very strong because the soil is highly fertile and the water in that area also is fertile. So the growth of Eichhornia is very, very robust, and the organism fails to control it greatly. So whereas, as Sushil Kumar told, in a new area where it got established, if it is combined with biology control and some mechanical removal or a chemical methods to control initially and followed by a biology control, you may be getting a control, provided we go for a regular removal of the re-emerging sprouts. So in a limited area, in a small pond or in a lake, that may be successful. But if the area is going to a large area into thousands of hectares of no man's land, we may not get success. So that is the experience world over. You know, Eichhornia is the #1 aquatic weed world over, and everybody is trying. And people have tried Neocotina along with fungal organisms combined, and there also we get a better control. But still, the effective control, we are yet to get the control. So probably a lot of research is needed on this area. And as Sushil Kumar told in the beginning, what we are seeing is there are a number of new aquatic weeds emerging as problems in our aquatic areas. Because, you know, the world trade is open, and transportation is throughout the world, people are all moving. And either for ornamental purposes or for curiosity's sake, people are all bringing new plants. And once they get into the new area free of their native organisms to control them, they get established easily. And that is why now we have serious problems from alligator weed, as well as we have Kabomba is becoming a serious problem. And in our rice fields, which people have abandoned, we are getting many other weeds like Hypomia, Carnia, and many other weeds. So wherever people are not attending, these aquatic weeds are likely to come. Another reason is the nature doesn't want vacant places. So when the aquatic bodies are so much exposed area is there, and if people are not attending to remove them as and when they control, it is so much of energy, solar radiation is coming, and in some weed, either algae or some other weed, which is ideal for that equation, is to come. So wherever people want in the recreation areas or agricultural areas or rivers, wherever we want to utilize those areas, it is our responsibility to keep them under control. If you leave it to the nature, then these areas are likely to be controlled. And another point we have to see is these aquatic weeds are actually the nature's God's gift to the human beings for cleaning the polluted water. So wherever we get serious problems of Eichhornia in the lakes or in the rivers, what we can see is there are a lot of soil eroding to that area, or factory waste or municipal waste, the drainage is going to that area. And the water becomes so rich in nutrients. And it is nature's way to clean this. And Eichhornia is in that condition, it is a blessing to clear the water from the pollutants. So if we want to get these weeds controlled, it is our responsibility. The municipal agencies, the government agencies should see that the effluents are not going into the water bodies. So only if we keep them under control, then only the situation it can be controlled. Even in Kerala, in the Kuttanad region, say 4 or 5 rivers are putting or all draining to that area. And from the higher hilly regions and the plantation areas, a lot of fertilizer containing soil is eroded to that area, and that is why the problem is coming. So unless we control the movement of nutrients and polluted water into the water bodies, we cannot control them. So in that aspect also, government has to give a control. And from our side, from the weed scientist point of view, I think so far we have not given due attention for controlling for research on control of aquatic weeds. We have given attention to control of weeds in the agriculture situation, but not in the aquatic areas. So I think we should hereafter we should give more attention for controlling these aquatic weeds also. These are some of my suggestions. Thank you for giving me a chance to express my points. Thank you.
Thank you, sir. Thank you. Thank you very much for your comments and remarks, sir. I hope Dr. Yain Rao is online with a request with 1 or 2 remarks, sir. Dr. Rao, sir, are you online?
Yes, Rao.
Yeah.
Yes.
Yes, Rao is and Yain Rao also. There both Raos are online. I request from both of you, sir, with 1 or 2 remarks.
Okay. Sushilji, can you throw some light on aquatic weed control in aquaculture? Aquaculture.
Yeah. Doctor, again, it will depends on what type of weed is there in aquaculture. So if you tell me the type of the weed, certainly, particularly in aquaculture, if it is a floating weed, like this alligator weed, or what type of floating weed is there. And because aquaculture, if it is a small pond or that area, certainly floating weeds means mechanical approach is very nice. But if it is submerged aquatic weeds, particularly in aquaculture, submerged aquatic weed also, they play a very important role as a problematic weeds in aquaculture. So again, that depends on the type of the aqua fishes you are going to rear there. Particularly in case of that, we have to make the combination of grass carp also. In those areas, if, for example, if we are also taking rohu or katla or mirgal, then we should also release grass carp. So grass carp is a fish which will take care of submerged aquatic weeds. So that's how, again, it will depend situation to situations, what type of weed is there and what type of management we have to do.
No, actually what is happening is sometimes the fingerlings are dying whenever they are using chemicals, particularly in case of typhoid. All these weeds are problematic weeds. They are very difficult to control. Of course, if there are like free floating weeds, they are easily removed by mechanical means and all these things. The problem is coming with the that is emerging weeds like the typhoid is there. Very problematic, very weed. In such cases, some people have used the glyphosate. That is 71% SG. Its control is good, but the thing is, what is its effect on the fish underlying?
Yeah,
that's why we
So you are rightly, you have already rightly pointed out that always when we talk about the use of aquatic weeds, we have to face many such problems. Effect of those herbicides on aquatic fauna as well as on water quality. So, for example, if we take the example Typha angusta, what the problem is in your aquatic culture. So if we use that, particularly typha is very tough aquatic weed. First of all, when we will spray the glyphosate or other chemical, then it will go to the root gradually. And if before that, it is particularly for typha, if we are able to cut the typha roots from below the 2 feet of the water level, then that's how 100% we can manage the typha. But by that use of chemical, again, there will be problem. If 50% we can have management of this typha, but again, emergency will be there, and lot of repetition we have to do. So
Yes.
that have to means that have to be recommended according to the situations of the aquatic weed.
Okay, thank you, sir. Thank you. I think I hope Chinnasamy sir is online with 1 or 2 remarks quickly, since the time is running. Our scheduled time is we have to close by 1 o'clock. So, Dr. Chinnasamy sir, please. Chinnasamy sir, are you online, sir?
Sir, give enough time for discussion, sir.
Oh, okay. It is,
It is just
there are 100 more questions are there.
Don't close at sharp 1 o'clock.
Okay,
you can extend the time if questions are coming.
No issues, sir.
Because
No issue. We'll
discussion is
extend.
very important part.
No issues, sir. No issue. We will extend. No issues. There are more than 100 questions are there. We'll try to answer all the questions by the speaker. And if Chinnasamy is not online, I think I request Prasad sir is TVR Prasad from Bangalore is online. Sir, any remarks on this presentation or your comments?
Dr. Sushil has done a very good job of summarizing the overall management of aquatic weeds. Yes, in various places. I think one point I would like to stress there is particularly use of grass carp in management of submerged weeds. They are quite useful. That also can be added as biological control method. So I think with this, he has covered almost all. Okay. I think I thank him very much.
Okay, thank you, sir. Thank you, sir. Thank you, sir. Participants, please. Anyone from
Dr. Chinnamuthu. Dr. Chinnamuthu.
Please. Das sir, please quickly with your remarks.
Yeah. So first, I congratulate Dr. Sushil Kumar because it is really nice presentation, much more informative, and he really took us to the real site where this problem is occurring. So it is really wonderful. So, but I think that is one important aspect what he has highlighted, that compost preparation from these water hyacinth. That would be very good approach, that compost wherever they are. But I wanted to know from him whether he has done it or not, but if you have any information. So how much this compost will be applied in the crop field? How much NPK supplement could be supplemented by this thing? Whether you have any information that from this water hyacinth compost, because this is the large scale. Because where there is a huge infestation of this water hyacinth, we can have a small industry like things like compost making by NGOs or even farmers themselves can do this thing. So that compost making would be very useful, that vermicompost, particularly vermicompost, and that would be useful, that nitrogen supplement could be done, and how much that fresh biomass of water hyacinth could be converted to how much biomass of that compost. Is there any sort of information from you you can share? That would be useful.
Okay. Thank you, sir.
Yeah, Dr. Das, actually, you know that water hyacinth is, or most of the aquatic weeds are having water, too much water. Means you can say 90 to 95% water is there in aquatic weeds, and that if we talk about the water hyacinth, in that about 92% water is there. So the biomass we are going to get only 10%. But that 10% is also very useful because particularly if we are making compost or vermicompost from the aquatic weeds, for other type of the agro waste, we need a lot of water and we need a lot of efforts to make vermicompost. But in my experience, what I find that if we use the aquatic weed for making compost and vermicompost, we need very less expenditure as well as very less water also. because they are laden with the water. They themselves, with the load of the water, they will disintegrate, and turning. And after that turning, we can easily introduce that vermi worms to make to convert them into that one. So I have prepared one very 3-minute or 4-minute one video also on that. Participant, they can search it in the YouTube by giving title vermicompost making from water hyacinth. I think a lot of information they can retrieve from that video.
Okay, thank you.
Thank you.
Lot of information, research information is available on that aspect.
Dr. Chinamuthu, may I have a couple of minutes?
Sushilji, I am Bodua from Assam.
Dr. Chinamuthu? Dr. Chinamuthu?
Hello.
So can I have?
Yeah, please, sir. Please, Gadesan sir, please raise your question, sir.
Okay, it's not actually a question. I just compliment Dr. Sushil Kumar for a very elaborate presentation. Just a minute. I have few remarks because I have worked to some extent in water hyacinth and other aquatic weeds. The first answer will be for Dr. Das. Is naturally when we compost water hyacinth, we have seen the conversion ratio is 36:1. Or somewhere around 35:1. If you have 35 kg of biomass, the composted material will be 1 kg. That is one thing. Second question, I would like to answer Dr. Bhaskar. When he was initially making the remarks, he was asking what will be the impact on biodiversity with aquatic control. Actually, see, for example, some of the aquatic weeds are complementary or supplementary to other natural plants, whereas some others are suppressive. Water hyacinth is suppressive, whereas lotus or nilambo is complementary. Because the reason is nilambo covers a larger surface and it doesn't deteriorate the dissolved oxygen, whereas water hyacinth deteriorates the dissolved oxygen. So it is always better to support nilambo or lotus than water hyacinth. That is one point. The third point which I would make to record is, see, we cannot simply recommend herbicide application, and somebody raised a question about aquaculture. When we think of fish culture or anything, say for example, using a herbicide, even if it has a label, is going to be highly deteriorative. We have seen experimented with most of the fishes, even if they don't die, there is a tissue deformation. So accordingly, the histopathological studies never recommend any herbicide for any aquatic weed control. So the mere claim for label claim for control of aquatic weeds can be done only when there is no organism other than the weed is there. That is one thing. The other thing is actually there are, say for example, the thing that DWR or other ICRIP centers need to experiment is the scope is large for inundative biocontrol. We have been talking about classical biocontrol, which has very limited use in seasonal water bodies. But inundative biocontrol or augmentative biocontrol with bioherbicides and microorganisms are huge. The scope is large and no one has experimented in India except 1 or 2. And that is the study to be taken up. So with these very short remarks, I just thank Dr. Sushil and others. Thank you.
Oh, thank you, sir. Thank you. I think industry side, Majumdar is online. Please, your remarks, please, sir.
Yeah.
Yeah, please, sir.
Dr. Chinamuthu.
Yeah.
First of all, I'd like to compliment Dr. Sushil Kumar for a very comprehensive presentation. I was also from our student days, that means 60 years ago I'm talking about. I remember a very famous scientist, Dr. Neelratan Dhar. He first mentioned about the water hyacinth and molasses as a very useful material for compost. Yeah. And I think, Dr. Sushil Kumar has done a lot of work on this. I think there should be some schemes maybe to promote this idea of using water hyacinth. What I would like to know, maybe I am not aware, is there any national aquatic weed management program or projects?
Dr. Sushil, sir, please.
And so far, there is no such a national aquatic weed program.
No, sir.
Yeah, doctor.
Only state level some projects were there, sir. State level
Yeah.
some projects. That's why I got an opportunity to work in it, in aquatic weed control project for some time.
Okay. Okay, Dr. Barua is online, sir. Please, your remarks and suggestions.
Sir, thank you. Just I want to point out something that Dr. Sushilji has mentioned that Salvinia molesta from Northeast. Actually, it is not here. Till now, we are not suffering from Salvinia molesta. We have some other species. These are not so much problem. One more weed is coming. Actually, it is published already in the current science in 2015, I think. It's a Ladrisia peruviana. So it is coming as a new weed, of course, new invasive weed. And not only the Ladrisia peruviana, alligator weed, Alternata phyllogeroides. So these are invasive weed and they are really threatening our native biodiversity. And we have to focus on that. And a very good presentation is given by Dr. Sushil Kumar. And Sushilji, thanks for that. But thing is that same thing, I think we are, when we talk about aquatic weed or aquatic weed management, always our attention goes to water hazard. And already we have achieved something. Now this is for implementation part, but our research focus should go to the other weeds, which are really problem, particularly those amphibious type of weeds. In crop field, you see, sir, Lyricia hexandra, a grass, and there are some other grasses also, like Oryza, Rufipogon or Nivera, and some Seciolepis, Hymanecti. These are some of the real problems in crop fields, particularly in the rice growing areas, not only in Assam, West Bengal, Manipur, in all these areas. And we have to give some more focus on that. Actually, I request Dr. Sushilji and some Dr. Abrahamji and Kathiresan, you gave so much very good comment, but we need some really applicable and practical management of this type of invasive which are really creating havoc in our crop field, particularly in aquatic systems. Thank you.
Yeah, thank you very much, Dr. Barua. Your points are very valid. In fact, I have gone through that paper, Ludwigsia peruviana. Certainly, particularly in Assam, you have categorized this. It is emerging aquatic weeds, and as rightly pointed out by you, we need to focus because now that weed is coming in Northeast region, and you are the most appropriate person, I think, to take some studies on particularly Ludwigsiana. And for alligator weed, of course, these amphibian type of weeds, as you mentioned, alligator weed is also coming as one of the most problematic weeds in Indian situations because now it has invaded many crops also. So some work has done on alligator weed at DWR on its nutritive quality as well as its management through chemicals and biological control aspects also. So some literature is available on that, but we need, as Dr. Barua has rightly pointed out, that we need to focus on some other aquatic weeds of different regional situations. Thank you.
Chinamuthu, shall I supplement?
Yeah, please, sir, please.
Sir, in case of the rice, particularly the Ludwigia, Pariflora, Pistia, all these are also some of the problematic weeds in low-lying rice areas. We conducted several experiments, particularly 2,4-diamine salt is found to be very effective. Similarly, ethoxysulfuron, metsulfuron plus chlorimimethyl, all these they will control the these broad without any injury to the rice. Just this is one supplement. Okay, thank you.
Dr. Chinamuthu, you take some questions
sir.
from
Thank you, sir.
audience they might have posted.
Yeah. There is one important question, sir, from Abhinav Yadav. What are the effect of herbicides on water after application? Will it have any effect on the water if you apply herbicide 2,4-D or any other chemicals? So what may be the effect he is asking?
Yeah, water quality certainly. That's a particularly we have done studies on the effect of herbicides on water quality as well as on non-target species, and certainly water quality is hampered. And particularly water quality is hampered when we spray of these chemicals on a weed biomass. Then certainly a lot of water quality is hampered. But alone, if, for example, water, some aquatic weed is there, and we want to control it by spraying on that weed. First of all, due to degradation, decomposition of that weed biomass, water quality is hampered. A lot of degradation will be of dissolved oxygen and other parameters. Okay. And initial studies on effect on non-target species also revealed that herbicides, they have detrimental effects on bioagents and other aquatic fauna and flora. Thank you.
Okay, sir. Okay. The next question is there any risk to be invasive which are using as bioagents? Is there any certainty that those bioagents will not affect the crop if it is used near the agricultural land? So, this is question from Ria Ghosh.
Yeah. So I would like to share that whenever under biological control program, we take bioagents, the first and most important criteria should be that the bioagent should not be eat any other vegetation. Means strictly it should be host specific. For example, we were talking about bioagents of Neucatina bioagents against water hyacinth or Cyrtobacter salvini against Salvinia molesta. These type of bioagents are very host specific. They will die, but they will not take any other vegetation except the concerned host. Means for Salvinia bioagents will take or eat only Salvinia. Not even it cannot eat any other aquatic vegetation. Likewise, other Neucatina species, whatever, if this is the utmost important criterion for choosing the bioagent, that it should be very host specific. I think now it will be clear to Ria.
Yeah, yeah, good. Another question from Jayanti Srikanth. She's asking about how to control this water hyacinth in the hydroelectric plant. So they are facing this kind of the biomass getting into the hydroelectric plant and creating problems. So what is the...
Yeah. In fact, this sort of problem is also there. We have visited Sarni. It is one of the dam in Betul district of Madhya Pradesh. So that reservoir is being used for generating electricity. So water hyacinth is one of the greatest problem there. But as I told you that in running water, particularly if there is a running water and there is infestation of water hyacinth, we should avoid to recommend any chemical because it attracts a lot of criticism. And in such situations, again, we have to opt integrated approaches. Means we have to, wherever it is feasible and fund is available, we need to remove the bioagent, that weed biomass. And after what mistake generally we do, that once some fund is allocated and we remove that aquatic body from the aquatic weed and then forget. So after sometimes again we restart to germinate, and 7 to 8 months again that whole aquatic body is full of water hyacinth or other such regenerating type of the weeds. So we need to take care that after doing such mechanical removal, then we have to monitor it time to time. So in that monitoring, certainly expenditure will be very less, 1/10 of the actual expenditure when it will be fully infested. And if a water reservoir is very big, and if we are having some sort of corners where we can push the water hyacinth there and we can make some barrier type of things, there we can reply. For example, in case of Sarni reservoir, because we have to avoid the current of the water, Because with the current, if we will apply the whole aquatic body, wherever we will release the bioagents will pass away during the rainy seasons. So we have to choose some corners in those of big reservoirs where we can push this sort of aquatic, particularly water hyacinths, and we can make a barrier so that they will not mingle with the current, and there we can release the bioagents. This type of the recommendation we have made to dam authority there in Sarni. So by this way, sir, we can manage. Thank you. Next
Okay,
question,
sir.
please.
Okay, thank you, sir. Another question from Subramaniam from Andhra Pradesh. Sir, what are the herbicides have label claim for use in aquatic bodies in India? Already, is there any registered chemicals or label claims in use in aquatic?
Yeah. Dr. Subramaniam, when we were initially talking about the chemical management, I told you that so far label claim is only for 2,4-D, and that very long time ago it was label claim was taken. And in fact, I want to say that many industries, they want to come up for the registration of the molecules against aquatic weeds. But particularly seeing the Indian associations, they don't foresee much lucrative selling of those herbicides, because in Indian situations the things are very different. Here that environmentalists, they always oppose of that chemicals. So this is the reason that even industry people, they are not coming forward to take label claim. Of course, a lot of work has been done on chemical aspects to manage the aquatic weeds. 2,4-D, glyphosate, metsulfuron, methyl, paraquat. These are some of the herbicides which are very popular to manage the aquatic weeds. So I think he will get the answer of his question.
Another interesting question from Naveen. He says that most of the aquatic weeds are broadleaf. Is there any specific reason for this kind of category? Most of the aquatic weeds are broadleaf weeds.
Yeah, so Naveen, what I wish to share with you that it is not true that most of the problematic weeds are floating weeds. In one sense, it is true because we are able to see them very clearly. For example, water hyacinth, alligator weed, salvinia, pistia, these are all floating aquatic weeds. That is the reason we quickly recognize that the whole river or the whole that aquatic body is choked with the water hyacinth or alligator weed. So, but in reverse, if we talk about the submerged weed, we will find that hydrilla, chara, algae, there are so many aquatic weeds, list of aquatic weeds which infest also aquatic bodies. So both submerged as well as floating weeds, both are very important to know that they are infesting water bodies.
Okay, sir. Okay, sir. The question from me, one question. Is there any growth retardants available to reduce the multiplication of this water hyacinth or salvinia? Is growth retardant, instead of trying with the herbicides, we can
growth
stop?
Retardant, particularly in terms of growth retardant, I think here people have not worked, and I have not also worked about the growth retardant, but in foreign countries, some work has been done.
Okay, sir.
Yeah.
Thank you, sir.
I think if you know,
I hope.
Dr. Chinnamathu, if you know, you please share with the audience.
Okay, sir. Okay. One of our physiology professor was used to tell use of abscisic acid will reduce the multiplication rate. Abscisic acid at different concentrations that will be useful for reducing the propagation. I think our Maslamani Dean Agriculture College Trichy is waiting. Do you have any, Maslamani sir, you have any suggestions?
Sir, I am giving compliment to the Dr. Sushil Kumar. He is giving excellent presentation. I am having one suggestion that is in SAR slides. In aquatic weeds, they are using chemical control knapsack sprayer or power sprayer. Nowadays, everywhere they are using for drones. In particular, in agriculture crop, they are using for herbicide, that is fungicide or insecticide. It is having a lot of problem for flower droppings and other things. When the sewage water particularly sewage tank and a huge area occupied by water hyacinth. Any possibilities for using drones to spraying for herbicides?
Yeah, that's you are right. In fact, now this drone technology has made dent in India also, and now experiments have been started to use herbicides through the drones. And I'm sure that the drones will be very helpful, particularly to manage aquatic weeds by chemicals, because there's the whole. If, for example, if whole that river or that aquatic body is full of floating aquatic weeds, then there will be a very less chances of the drift of herbicides also. But as usual, I told you that herbicide, there is no label claim of herbicides in India except 2,4-D so far. So while we will be using chemicals, particularly herbicides against the aquatic weeds, then we have to take care of those all things. Thank you.
Okay. Thank you, sir.
If I may just add.
Yeah, please, sir. Please, sir.
Yeah. I think the drone, it is under discussion in the ministries and registration committee and all that, but it has not yet been officially approved.
Yeah.
Except in the control locust, locust, and the special permission drones are used. But many countries have made so much of progress, including on about China. But India, we're still struggling. There are a lot of, applications for use of drone in agriculture, application of insecticide, herbicides, fungicides. But officially, we are still awaiting the approval.
But it is one of the easiest way to cover the area very quickly.
Exactly.
Yeah,
And
yeah.
lot of benefits are there. Lot of benefits.
Our TNAU scientists also are having projects on the application of herbicides, either for pre-emergence or early post.
Sir, I will supplement, sir.
Yeah, Murali Athanari.
Sir, sir, thank you, sir. I compliment our Sushil sir for an excellent presentation. Actually, for supplement, adding some more points to Masilamani sir queries. So we have conducted 2-3 experiments on herbicides application through drones, sir. It is working very well. Then efficacy also more than 80%. We drastically reduced the spray fluid requirement from 500 liters to 30 liters per hectare. So that way the efficiency and the time of application and the method of placing the droplets on the weed surface also is more. So we have studied very well. I think there is no issue for using drones in aquatic system also, sir. This is my, I would like to add some more points in this drones application. Sir, it is working very well. We have conducted 3 experiments already.
Okay, thank you. I hope, I think there are so many questions. Let us direct the questions directly to the speaker. He will answer to your mail IDs. So now it's time to going for concluding remarks. I request the Honorable Chairman for his concluding remarks, followed by Dr. Mishra sir will give remarks. I request Dr.
Dr. Chinnamuthu sir.
Oh, please, sir. Please.
I think the chairman should, after chairman, there should not be any remark.
Okay, sir. I request you.
I will give some point, then after chairman, then chairman.
Okay, sir.
So, thank you, sir, Dr. Chinnamuthu sir. So, let me compliment Dr. Sushil Kumar for very comprehensive talk on the management of aquatic weeds, covering all floating and submerged and other weeds, and followed by a very fruitful discussion. I think this is the first time when such large discussion and very good points has emerged from the participant side. I feel some of the issues, rather I can say researchable issues, because if you see that so far we have not worked the management of aquatic weed in a holistic manner. Means using the, say, if take the example of herbicide, people have taken the herbicide, glyphosate or paraquat or 2,4-D, and just how much control is there. But until and first of all, because water is a multiple use commodity, so use of herbicide in water is very restricted. And even if we are using some of the herbicide, then certainly we have to see that what is its effect on the water quality, water aquatic flora and fauna. And moreover, when this biomass is decomposed, how it is going to affect the dissolved oxygen of the water. And then, because we know that all these fishes and other things, they hide on the aquatic beads. And sometimes the fishes use the aquatic beads as a food. So under those scenario, if there is no aquatic bead, or if decomposed aquatic beads are there, how they are going to affect the fish production or the productivity of the flora and fauna. So that's what I am saying, a comprehensive study, in toto study is required when we talk about the management of aquatic beads. Second point is the utilization. Yes, because the aquatic beads are mainly managed by the mechanical tools. So once these aquatic beads are removed out of the aquatic bodies, so certainly the utilization part is very important, whether it is a decomposing purposes, that vermicompost. And I do agree with what our senior colleague, Dr. C.T. Abraham told, that the phytoremediation, because these aquatic beads have a good capability of the removal of the heavy metals from the water. And we know that a lot of effluents from the city waste used to come from the city ponds, like Motijil of the Motihari. So until and unless the policymaker, the government, the municipality has make a provision to do not use those heavy metals in the water, I think the removal of these beads, that what Dr. Our chairman in his introductory remarks said, that we have to see the trade-off between the management as well as the benefits of the aquatic beads. And then certainly the bead flora shift, because we have very nicely cleared the Motijil of the Motihari, but again there was a shift of the other aquatic beads of the Pistia and Salvinia were coming out. So once we clear a particular aquatic beads, certainly there is need to monitoring, regular monitoring is required, because once the version of one bead is over, the other bead are inbetting and they used to invert the feed. And the climate change issue is very important, because it will not only affect the ecology of the aquatic bead, but also the activity of the bioagents. Because the bioagent we are doing here in the limited condition, the efficacy of the Parthenium bioagent and this Neocatenae bioagent under the changing climate scenario. So that is also going to be affected with the increasing temperature and their efficacy. Then because we largely depend on the mechanical means, and we have seen in the pictures presented by Dr. Sushil Kumar, a lot of JCB machines and other things are being used. And I think that is the one way and the important way to clear the aquatic bodies. But there is a need to develop the need-based low-cost aquatic beaders, so that they can cut and collect the beads from the aquatic system. And I think I have covered most of the points. So with this, once again, I congratulate Dr. Sushil Kumar and also the participants who have very actively participated in the discussion program. So thank you very much.
Thank you, sir. Thank you, Dr. Sir, for your wonderful remarks. I request now the chairman of this session for his concluding remarks. I request Dr. Bhaskar sir, please.
Thank you. Of course, it was indeed a very good comprehensive deliberation by Dr. Sushil Kumar. I know he has taken us to different parts of the country to really show the problem of aquatic weeds in many parts, many agroecologies. And as pointed out by our director, there is a great need to take up some integrated studies, whether only mechanical study is sufficient, and in each kind of lake and in each kind of weed. That is very important. So weeds also do matter, at the same time location, and whether in the first place, whether weed control in such ponds is required or not. Wherever we are worried about the economics of the activities, livelihood activities and other things. Under such situation, we need to estimate also properly. If at all you are going to control the weeds, how much is going to be benefited? And after removing the weeds also, so he has shown many slides that it can be used for the compost preparation and other things. So when you do that, so what is the kind of benefit you are going to get for the community itself? Because many of the lakes, ponds and other things belong to community. So unless we pool the community there, nothing can be achieved. That even if you get the JCBs under Manrega for removal of these weeds, again it has to be composted. For that also we need some kind of help from the community. And how do you redistribute that the benefits accrued from such composting activities to the local community is very important. Then you can attract them also. Suppose if you give back the compost prepared by this aquatic weeds, no doubt they will come forward. But Katreshan has pointed out very good thing that ratio, it's about very less. I think when you get about 35 kgs of water ice, and it will give you 1 kilo of this thing. So I think ultimately the amount of compost we are going to get from the big biomass is also less, because 70 to 80% of this aquatic weeds is comprised of the water only. Not much biomatter is there. So that is one aspect. Then somebody has also raised the use of drones for chemical weed control of the water acid. Of course, the limitations is very well been explained by both Sushil Kumar as well as the Dr. Mishra. There is a limitation. We can't straight away get into the chemical weed control in any of the ponds, because water contamination is much more severe or serious than the soil pollution, we can say that. So suppose even if soil polluted, by going for some other the aspects, it will have its own buffering capacity. To tell you frankly, soil is having much more buffering capacity compared to the water. So as water is direct, if chemicals are put into the water, first of all, we have got problems of the heavy metals there. So in addition to that, you are adding these metals also. So the chemical pollution of the water will be compounded. So it is on one way we are telling that the phytoremediation by these weeds. On the other way, you are putting the weeds again chemicals to that. So how do you come out of these problems? So don't aggravate the problems. While solving the problems, we should not aggravate the problems. Therefore, of course, in small and medium lakes, I think we can still go ahead with the mechanical weed control only. Using Manrega and other, you have to converge your programs into some of the central sector schemes and the state funded schemes. So therefore, it can be easily removed. And the involvement of the community, I am telling you, unless community participation is there, it cannot be removed. See, you have seen strict vigilance should be there. The Sushil Kumar has pointed out at certain points, strict regulations, strict vigilance. And we have been observing during the corona, how many of are observing the strict code appropriate behavior? We are not. See, when we have not cared for our lives itself, do we care for the weeds which are there in the lakes? So that is a kind of attitude. See, we have to change our attitude, mindset, and all those things, while particularly to come to control these weeds in public places and all those things. Most of the lakes and other things, it belongs to either communities, or in if you say reservoirs and also, they belong to the irrigation departments. But as far as irrigation canals are concerned, of course, there is a work also. Every year they need to remove the weeds from the canals and all those things. I don't know, many of the irrigation departments are not attending to it. That is an unfortunate part in the country. In many of the states also, we have seen that every year they need to remove the weeds in the irrigation canals. So that is going to reduce much of our weed problems. So it will not contaminate the other water bodies when you remove it. So as he pointed out that before onset of the monsoon or before filling up of the tanks and all those things, if you remove most of the weed seeds and all those things, I think we can come out of this problem. That is another, prevention is the best thing here. Second thing is, is there any mechanism to prevent the germination of the weed seeds? Suppose a dry lake is there and weed seeds are being entering into the dry lake. So how do then can you have some kind of pre-emergence or kind of this thing, so that it will not germinate even if water is going to be filled in the lakes. I think that will have some amount of impact, control measures compared to the after allowing it to grow in the water bodies, then take up the chemical weed control. I think this kind of one approach, I think it can be, pilot studies can be initiated by the DWR in selected centers. So those centers which are working very dynamically in this aspect, they can choose these centers and they can go for that. Even drones also, you can try the chemicals. I don't know, many of them are contact herbicides. They don't get into the plant system. Whether the systemic ones are correct or the contact ones is sufficient, or and how the residues will remain in the water, how it will be passed on to the any other thing, maybe a fodder crop grown in the by using that water, or any other crop, how it is going to be residues will be passed on to the crops and the animals and all those things. Milk we have to find out. So that kind of analysis is required if at all you want to choose the chemical weed control. So coming to the biological weed control, of course, the main problem is about the multiplication of the bioagents. So of course, they are also season bound sometimes, and they need their own time to multiply. So every year we need to release them in certain places and all those things, and continuous supplies of the bioagents from these particular agents, or I don't call it as agents, our own scientific centers is very, very important. You have to ensure the quality bioagents for control of the weeds. So these things are some of the approaches. I think there should be some kind of policy on this. And one more thing, Dr. Mishra, can we have some one or two experiments? Of course, we are going to discuss this in the next ASRP also. Say you are scheduled for June 18th and 19th. We can think of initiating some small experiments across the centers. Then we can have some kind of figures. And ultimately, you only said that we don't have any data bank about the lakes or the water bodies. So data bank has to be created. Some kind of mapping is required, and you come out with the economic classes due to aquatic weeds, exact classes, and where it is required, where it is not required, and also. So thank you very much for giving me an opportunity.
Okay, thank you, sir. Thank you very much, sir. We will. I think you have highlighted the points like exhausting weed seed bank. This is one of the important area. So our centers of DWR will take care of that the future programs. Drones, residues, biological agents, policy making, and network experiments, and data bank and mapping also will be done by all the ICRIP weed control centers, sir. So the points are well taken. The future program of our weed control, aquatic weed control work. Dr. Mishra, sir, you want to give any?
No, sir. Thank you.
Okay, sir. Okay, sir. So let us move on to the. Sir, thank you, sir. Thank you very much. The remarks of the chairman. So let us move on to the final session. Vote of thanks. So I propose myself the vote of thanks. Before that, I very much happy to note that there was an overwhelming response from the students and the scientists. Some of them were unable to join the webinar since I'm sorry to inform that the software is not permitting to join more than 500 participants. I think around 200 participants were unable to join. So they are complaining and giving remarks on this. So I think this is the capacity of the software to hold. So of course it was a lengthy session.
You could have also provided the YouTube link, you know.
Yeah, sir. We have given Facebook live streaming, sir.
Okay.
They have also joined. So of course it was a very lengthy session. Still there were 300 participants were online towards the close of the session. So let me come to the final vote of thanks. I profusely thank our ADG, Dr. NRM, Dr. Bhaskar sir, for sparing his valuable time to chair the webinar and his remarks during his busy schedule in the pandemic situation. So thank you, sir. Thank you very much for your patient participation throughout the length of the session, sir. So I take this opportunity to wholeheartedly thank the Director DWR and the Secretary of ISWS and as well as Organizing Secretary of this webinar, Dr. Mishra ji, for organizing this important event. This is the 5th seminar, is very successfully organized. So thanks to the speaker, Dr. Sushil Kumar sir, for his elaborative information about the aquatic weeds, their impact, management of these weeds, and the effective participation in the discussion part, also answering all the questions from the both participants and from the other things. So I thank all the veteran and eminent scientists like Abraham, Dr. Sinusamy, Dr. S. Rao, Dr. Prasad, Dr. Gadireshan, Dr. Majinder, and Paruva, and many other senior scientists were also in line and they participated and they are given their remarks. And so thank you, sir. Thank you all the veteran scientists. So I thank all the ISWS members, office bearers, senior scientists, research scholars, students from all over India for your enthusiastic participation. I thank all the DWR scientists and staffs for their active participation and assistance in the conduct of the webinar successfully. So I thank the computer person. I think Ganendra Pratap Singh is the most important person helping us to the smooth flow of this seminar. So I thank Ganendra also. I thank ICR finally permitting to conduct the webinar and permitting the scientists to participate in this event. Of course, this is a working day, so scientists are participated. I thank ICR finally also. So once again, I thank all the participants for your effective participation. Thanks for the opportunity and thank you. Take care, be safe, follow the SOP of COVID-19. So great day. With the permission of the chair, I request to close this session, sir. With your permission, Dr. Chairman, sir. So we will close this session. Now you can leave this program. Thank you, sir. Thank you, Anandal.
Thank you, sir.
Thank you very much. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you to all.
Thanks to all, sir.